Hello, pre-algebra students. This lesson is going to be on two-step equations. To help you prepare for this lesson, I strongly encourage that you go ahead, pause the video here, and try these 4 warm-up questions, and then check back in because these warm-up questions come from yesterday's lesson on one-step equations. And like the name suggests, it goes first one-step equations, and then we learn about two-step equations. So they're going to be related. We're going to use a lot of what we learned in yesterday's lesson on one-step equations. So these warm-up questions will help you get ready. Go ahead, pause the video now to try them, and then come back to get those answers. The main idea we learned in our lesson on one-step equations is that when you're solving equations, you always want to do the opposite to help you figure out what that missing number is. The equation in number 1 says x plus 4 equals 12. We're trying to figure out what number plus 4 equals 12. The work that goes along with it is the opposite of whatever math we see. So here I'm adding 4 to x. I would do the opposite, which is subtracting 4 on both sides, and that leaves me with x equals 12 minus 4, which is 8. That means that missing number must be 8. 8 plus 4 does equal 12. We continue the idea of doing the opposite, and number 2, I would need to do the opposite of a negative 3 to get y all by itself. The opposite of negative 3 is a positive 3. And once again, we always do that on both sides of our equation. Negative 3 plus 3 gives me that 0. 0 is nothing, so I can say those cancel out. And I get y equals negative 9 plus 3, which would be a negative 6. That must mean that negative 3 plus negative 6 does in fact equal negative 9. Our missing number was negative 6. That third problem says negative 6t equals 18. We need to remember that when you have a number and a variable right next to each other, like we have a number 3, it means multiplication. So the opposite would be division. I want to divide both sides of my equation by that negative 6. Dividing by negative 6 because that's going to help me cancel out those negative 6's and get t by itself. This time the negative 6 cancel because negative 6 divided by negative 6 equals 1, and 1t is just the same thing as t. So similar to number 2, it's canceling out, but for a different reason. Here we just want to get 1t, or t by itself. And then on our other side, 18 divided by negative 6 equals negative 3. The final one, we've got w divided by 5 equals 10. I'm trying to figure out what number divided by 5 equals 10. And so I'm going to do the opposite. The opposite of dividing by 5 is multiplying by 5. I usually, just personal preference, I put the multiplying 5 up here instead of underneath. And then just like in number 3, that multiply by 5 divided by 5 is going to cancel out and leave me with w. And then 10 times 5 is 50. We figured out that missing number must be 50 because 50 divided by 5 does equal 10. Like I said, this comes from yesterday's lesson. If you watched me do those 4 warm-up questions and you're like, whoa, what is going on? Please go back and watch the lesson video for one-step equations because that's really where we spent a full class talking about how to do these. But this is going to be what we need to do today's lesson on two-step equations. And so we will jump right in. The goal, as I keep saying, is all about how to solve two-step equations. When we solve these equations, we're going to be using a lot of these same ideas. There might just be a little bit more going on in our equation. To give you an idea of what a two-step equation looks like, we're going to start right here. I am currently thinking of a number in my head. And unless you are a mind reader, you do not know my number. So since that is a number that you do not know, we could use something like x to represent that number in my head. Now I'm taking that number that you don't know, and I'm going to multiply that number by 3. How could we represent that? Well, we're taking my number, which is x, and multiplying it by 3. So we want it to say x times 3. Or we've said the more common way you might see that is 3x. 3x means 3 times x. I'm now going to take that result, and now I'm going to subtract 4 from it. So again, how could I use math to represent that? Well, I could say I'm taking that result, my 3x, and now I am subtracting 4. So if we pause right here, notice there are two things we've done to my number. We've multiplied it by 3 and we have subtracted 4. And after doing those two steps, I'm going to tell you that it equals 11. So now we know that this thing I had earlier must equal 11. What we've just written right here is an example of a two-step equation. That is a two-step equation because there are two things I did to x. Remember, we multiplied it by 3 and we subtracted 4. And so to get x by itself, it means there's going to be two things I have to do to solve. And the way we're going to solve is like this, except going backwards. Because our goal when we're solving is always getting x by itself, I'm going to have to undo these two steps, similar to how we undid the stuff in the warm-up. We're doing the opposite. And because we're working backwards through this, that's also the order we're going to do. When we talk about solving two-step equations, we always are going to undo that minus 4, that's subtracting 4 first, and then undo that multiplying by 3. To help us talk about how we're going to solve this two-step equation, there's some vocabulary we're going to look at. In that equation, and I've just got the same equation down here, 3x minus 4 equals 11, there are two numbers we're going to have to get rid of, that 3 and that minus 4. The 3, you've heard this word before. We call the number in front of a variable. Does this word sound familiar? Our coefficient. Remember, that's the name of the number in front of the variable. And I'm also just putting here as a reminder to remember there's multiplication happening there. The name of this other number in our equation is nu. That number that you add or subtract in an equation, we call our constant. So in this equation, -4 is the constant. When it comes to solving this equation, remember, we're working backwards through this. So the first thing I'm going to undo is that minus 4, the constant, and then we'll worry about that multiplying by 3, that coefficient. So these are the steps we use when we solve two-step equations. We always start by getting rid of the constant, and then we get rid of the coefficient. And you might want to copy down those steps in your notes. When it comes to solving two-step equations, they can be harder to do in your head. I know when we talk about solving one-step equations, lots of times there are students who are looking at those nice, easy one-step equations and saying, oh my gosh, this just means what number plus 1 equals 3? I know that number must be 2. And pretty easily are able to say, just looking at it, that missing number is 2. I don't need to do any work. I don't need to do any explanation. I just know. But with two-step equations, there's more going on in the equation, and sometimes it can be harder for students just to look at this and say, I know what number x might be, because there's more math happening in the equation. And that's okay. That is where all the stuff we learned yesterday about doing the opposite and what we're learning today about these steps here will help us solve this two-step equation. I'm going to start the same way we did yesterday. I'm going to draw my line at my equal sign. And we said we are going to start by getting rid of the constant. I'm going to start by canceling my constant. We said earlier the constant is that -4. And yesterday you learned how to do this. If you want to get rid of that -4, what are we going to have to do? The opposite. The opposite of -4 is +4. And just like we did yesterday, we will do that on both sides. -4 plus 4 gives me 0, so I can say those cancel, and I am left with 3x equals 11 plus 4, that is 15. The difference is yesterday we only had to do one thing, we only had to do one step, and our equation was solved. But here, notice, I'm not done. I'm not done because our goal is to say x equals a number. But here, I don't have x equals. I have 3x equals. So there's still a second step to do. Hence why these are called two-step equations. My first step is in pink, but my second step is I need to cancel the coefficient. I need to get rid of 3. And to do that, that's what you learned yesterday. This is multiplication. I need the opposite, which is division. So I will come in and divide both sides by 3. When I do that, 3 divided by 3 is 1x, or just x. My 3's are canceling. And then on my other side, 15 divided by 3 is 5. And now that I've done the second step, I see I have an answer. X must be the number 5. When it comes to checking your answer, I had these steps earlier. We can always check by thinking about this. If my number was the number 5, that means when I multiply my number by 3, it gave me 15. And then if I were to subtract 4 from that, 15 minus 4 would give me 11. However, if you didn't have these words here, you could always check your answer, which I've got here as our last step. You should always check. You could check your answer doing the same thing we did yesterday, using substitution. We've seen this word substitution before. Do you remember what substitution is? Substitution is that idea of replacing. You take out the variable and you replace with a number. So remember, we wrote this equation saying 3 times some number. We didn't know what that number was, which is why we called it x. 3 times some number minus 4, we know gives us 11. Well, we think we know what that number is now, so I could replace x with what I think it is. I think it is the number 5. And then the way we check our answer is we check to make sure that left side equals 11. When you do that math, 3 times 5 gives me 15, and 15 minus 4 does give us 11. Sometimes you'll see people stop here, or sometimes you see people actually say 15 minus 4 is 11, and we've got they're equal to each other. So this is the big idea for today. I've got a lot of different examples for us to look at together, but this is what we're going to be doing, is solving two-step equations like this. We always start by finding the constant. In this problem, that constant was that minus 4. Your constant is always the number that's added or subtracted. And then our coefficient. Our coefficient in this problem was the number 3, and it's my coefficient because it's the number in front of my variable. After that, you can always check, especially if you're doing this at home and don't have a teacher to tell you, yes, you've done it right. So let's go ahead and look at some more examples here. I've got 2 more on this screen. Number 1, we can start by doing the same thing as always, drawing that line at that equal sign. And then I want to look at the side with the variable. In this problem, that is over here on the left. We've got 2 numbers we're going to have to get rid of to get y by itself. I need to cancel a negative 2, and I need to cancel the minus 5.8. We always start, we said, with the constant. So in this problem, which number will I start with? In this problem, my constant is that 5.8, that minus 5.8. I know that's the constant because it doesn't have the variable. It's the number that's being added or subtracted. So this is where I need to begin. And we always do the opposite. So the opposite of subtraction is addition. I'm going to add 5.8 on both sides. When we do that, negative 5.8 plus 5.8 equals 0. So those cancel, and I've got negative 2y over here on the left side. And then on the right side, 7 plus 5.8 would be 12.8. That's my first step, is here I get rid of the constant. That is everything in pink. Now our second step, I've got negative 2y equals 12.8. Do you know what our second step is going to be? My second step is I need to cancel the coefficient. And here that is the number in front of my variable, so that is the number negative 2. Negative 2y means multiplication, so the opposite is division. I am dividing by negative 2. You need to divide by the negative sign as well, because that will give us a positive 1y, or just y. And then my final answer, 12.8 divided by negative 2. Positive divided by negative is negative, and 12.8 divided by 2 is 6.4. That right there is what we think the missing number is. The way we check it is by substitution. We're going to take our equation, and I'm just going to copy it exactly how it is. And remember, it's all about what we think this missing number is. That unknown number, I think y is negative 6.4. So I'm going to leave everything else in the problem the same. None of that changes. And the only thing I'm going to change is I'm going to replace my variable, my y, with my answer. So I take out y and I put the number I think y is. I think y is negative 6.4. Now that I've done that, I'm just checking to see if I do all that math, does it give me 7? Well, negative 2 times negative 6.4 gives me a positive. Gives me positive 12.8. And 12.8 minus 5.8, yep, that is 7. That helps me know that I have found the correct missing number. There's only one number that when you multiply by negative 2 and subtract 5.8 gives you 7. And we have found that one number is negative 6.4. For this other one over here, I'm going to get it started and I'm going to encourage you to see if you could finish it. For number 2, I'm going to start the same way. We like to draw the line at the equal sign. And then see if you can figure out what is the first thing we're going to need to cancel. Well, when I'm trying to decide, first find which side has your variable. In number 2, the variable is over here, so that means these are the numbers we need to cancel. I'm going to have to cancel 6 and that negative 3. Now we said we always start with our constant. So here in my first step, I need to get rid of the constant. Did you figure out which number is our constant? Our constant here is going to be the number 6. It's on the side with the variable, but it's not the number next to the variable. That would be the number 3, right? 6 is that number that we're adding or subtracting. I need to start by getting rid of 6. Now that 6 is positive, so when I go to do the opposite, I want to subtract 6 on both sides. I can confirm that by actually doing this math. 6 minus 6 gives me 0, which is nothing. So I've got the 6's have canceled. So when I go to write my new equation, 27 minus 6 equals 21. So we have 21 equals, be really careful what should go over here on this side. Not just 3D. Remember that 3 is a negative 3. I need to say 21 equals negative 3D. That's why I wanted to start this one with you to make sure we all have that negative sign in front of our 3. Now we just have a one-step equation. So using what you learned yesterday, see if you can go ahead and finish this problem. What would our last step be? I've written off to the side. Our second step is we have to cancel that coefficient. Here it is that negative 3, so you should be dividing both sides by negative 3. Negative 3D is multiplication, opposite is division. When we do that, we get D equals 21 divided by negative 3. That would be negative 7. So we think the answer for this one here is negative 7. We can always check by doing substitution. Take your equation, 27 equals 6 minus 3D, and substitute. That means everything in my equation is staying the same except for that variable. I'm taking out the variable, no more D, and I am replacing D with the number I think it is, and I think the answer is negative 7. We will know if we have the correct answer by doing this math here. When I go to do the math, we've got 6 minus 3 times negative 7. Using your awesome order of operations skills, where would we start? With the subtraction or the multiplication? Multiplication. Think PEMDAS. Multiplication comes first. So I'm going to do negative 3 times negative 7. That is a positive 21. And 6 plus 21, yes, that does give me 27. That helps me know my answer is correct. This idea of using substitution to check is great for so many reasons. First, substitution is a skill you need in math. We are going to do so much substitution between now and algebra class, so it's great practice for future you. It's also great because you can do this for any equation. If you are not sure if your answer is correct or not, you can always take your answer, put it into the equation, and we should see something like this. We should see it's true. If we were to get a different answer, a wrong answer for this, maybe if I thought D was the number 1, if I were to put that into my equation, I would have 27 equals 6 minus 3 times 1 is 3. I would have an equation saying 27 equals 6 minus 3. And I know that's not right because 6 minus 3 is 3. Something like this would tell me, oop, my answer is not right. Let me go back and see what mistake I made. That's super important, again, for if you're doing math at home and you don't have someone to check your answers, or during a test where you really want to make sure you got that right answer. So we're practicing a skill that can be helpful for a lot of different reasons. Speaking of practicing skills, look, there are 3 more on this slide. These are all for you. I'm going to encourage you, go ahead, pause the video, and then come back to get some of these answers. All right, hopefully you've tried these on your own and you're coming back to get some answers. I got them started for us and then I figured we could finish them together on camera. The first thing for number 3 you had to do was get rid of your constant. Here it's that plus 12, so I'm subtracting 12 on both sides. That helps because 12 minus 12 is 0, so it is all gone and leaves me with negative 5m equals 20. My next step is I have to divide by my coefficient. Negative 5 divided by negative 5 gives me 1, or 1m is just m. And then on the other side, 20 divided by negative 5 will give me my answer of negative 4. That was the answer for number 3. For number 4, we've got negative 18 equals 9 minus 9b. I start by getting rid of my constant. Here, the constant's over on the right side because that's where my variable is, and it's this 9 right here by itself. So 9 minus 9 gives me 0 and gives me this new equation, negative 27. Negative 18 and negative 9 are both negatives, by the way, so we're just adding to get a bigger negative. And then on my other side, make sure you brought down that negative sign on that 9b. We get negative 9b. My final step, I need to divide both sides by my coefficient. If I do that, negative 9 divided by negative 9 cancels out, and we just get our b by itself. And then over here on the left side, this is going to be where the answer shows up. Negative 27 divided by negative 9. Well, a negative divided by a negative gives me positive. 27 divided by 9 is 3. B equals 3, or 3 equals B. That would be our answer for number 4. For number 5, I got it started. It looks a little different, but we start the same way as always, right? My very first step is get rid of the constant. And so that is what I have done in pink. My constant is that minus 4, so I did the opposite, which is adding 4 on both sides. Negative 4 plus 4 equals 0, so those have canceled out. And so I get my new equation, g divided by 2 equals 12.1. It looks different from these others, but you saw equations like this yesterday in our one-step equations. This is division, so I need to do the opposite, which is multiplication. I'm going to multiply both sides by 2. That gets rid of my dividing by 2. And so we get g all by itself over here on the left side. And then on the right side, 12.1 times 2 gives me 24.2. Remember, for any of these, maybe number 5 because it looks different, you could always check your answer. Remember, checking your answer, I think sometimes it helps just to copy the equation exactly how it is first. And then we're going to substitute. That means I'm taking out my variable and I'm putting the number I think it is. I think the answer is 24.2, but let me check. 24.2 divided by 2 gives me 12.1. And yes, 12.1 minus 4 does in fact equal 8.1. That's how I know I've got the right answer. For a lot of these problems, we're just solving them in these examples, but on the homework, there's always a variety of questions. So one of the questions you might see is an error analysis problem. So I wanted to give us a chance to try this as well before you start the homework. It says talk with a partner, but I'll have to be your partner. This one here, we've got Lindsay solved the equation below. Did she solve it correctly? If not, explain her mistake. And we've got this right here is the equation she's solving. We can see her work, and she got the answer x equals 3. For a lot of people, it can be challenging sometimes just to look at someone's work and find a mistake. Usually, the mistakes made in these types of problems are really common mistakes. They're mistakes that, if you're not doing it really, really carefully, you might make the same mistake too, especially if you're just looking at someone's work. So, a strategy you can always do is hide her work, cover it up, and try the problem yourself, and then compare your work to her work. So, for example, I might, oh, look, I can cover it myself. Can I cover it? Oh, maybe not that way. Maybe with this shape. I'm going to cover her work. There we go. Cover her work for now, and let's solve it ourselves, and then we can compare her work with our work. If this was the equation we want to solve, where would you want to start? I'm sure you're at home saying the constant. And if you were, you're correct. I'm starting with my constant, which here is the number 2. Now, what math do we need to do to get rid of the 2? That subtraction sign here might make you want to say add, but remember, we always have to look at the sign of the 2. The 2 is positive. It's a positive 2. So the opposite would be negative 2. I want to subtract 2 on both sides, because if I do that, 2 minus 2 is 0. That's nothing. And so I've got negative 4x on my left side. And then over here on my right side, 14 minus 2 is 12. That final step, negative 4x equals 12. This is multiplication, so I do the opposite. I divide by negative 4, and I've got the answer x equals 12 divided by negative 4 is negative 3. We could always check our answer too, just to make sure we've done it right and we're not making the same mistake Lindsay's doing. I could take our equation, 2 minus 4x equals 14, and substitute. That means I'm taking out the x, so I'm going to erase that and putting what I think the answer is. I think the answer is negative 3. 2 and negative 4 times negative 3 is a positive 12. And yes, that helps me know I have the right answer. You have the right answer. The right answer is negative 3. Let's see what Lindsay did now. Okay, so right away I noticed she got a different answer than we did. So that question, did she solve it correctly? We can go ahead and answer. We could say she did not solve correctly. If not, she did not solve it correctly, we want to explain her mistake. So we've got our work right here. We can compare the two and see if we can find where is that mistake. Go ahead, take a moment and see if you can find it. As I'm comparing, I know she started the same way. She subtracted 2 on both sides. So just like we have those 2's cancel out. But the next line, she wrote 4x equals 12, and I see we wrote negative 4x equals 12. Remember how we talked about these are common mistakes? A common mistake a lot of students make is they forget that minus sign. They forget to bring it down. And we know how math goes, right? If you make the mistake up here, it's going to affect the rest of her problem. So my answer, I don't need to say she did this wrong, and then she did this wrong, and then she did this wrong. Only the original mistake. So she did not solve correctly. She forgot. And then we're going to talk about this minus sign here. I don't want to just say she forgot the minus sign, because I might ask you where. There should be a lot of minus signs in this problem. So this is where that vocabulary can really be helpful. She forgot the minus sign on, what is this number called? You know what it's called. Coefficient. So we could say she forgot the negative sign on the coefficient after the first step. Something like that would be great because that's letting me know exactly where to look. We're saying after the first step, so that helps me know I'm looking right here, not at the very bottom of the problem. And you're telling me exactly where that negative sign should be. It shouldn't be on the 12. It should be on our coefficient. It should be on that 4x there. This would be a great example of how to answer one of these problems. There is one final one since we did this one together. This one is all you. Same idea. I'm going to have you pause the video, see if you can find where the mistake is, and practice writing out these answers because sometimes they're challenging. Once you have tried this problem and you have an answer ready, go ahead and press play again to get the answer. All right. Hopefully you are coming back now to this video with an answer in mind for this. Maybe you solved the problem yourself first and used that to help you find the mistake. I've got where the problem area is in this yellow box here. That first step is correct, but in our second step, looking at this work, Sarah added 3 on both sides. Now, why is that not correct? It has to do what this part right here means. Negative 3b means multiplication, and so we are always doing the opposite. The opposite isn't going to be addition. The opposite would be division. So is she correct? We could say Sarah is not correct. When I'm describing what's wrong, it can help to include what she did sometimes. So we could say she added 3 in the second step instead of, what we could say next, instead of dividing. Now you could say dividing by negative 3, or you could show off some vocabulary instead of dividing by the coefficient. Again, that's a great opportunity to use that word. Anything like this. The parts I would really be looking for if this was a homework question is this idea that we need to divide by the coefficient. This is the most important part here, is if you're mentioning in your answer something about dividing by negative 3 or dividing by the coefficient, that is the most important part. Hopefully you found this video helpful and feel better and more confident about solving two-step equations. Remember, there's the homework that goes with this lesson as well. That'll give you more chances to practice two-step equations. This lesson is going to be really important for the next couple lessons that are coming up. The one tomorrow is looking at stories that use two-step equations. And then afterwards, it's like you can probably predict where we're going, right? We learned about one-step equations, then two-step equations. So after this comes equations with even more fun associated with solving them. Again, thank you so much for watching this video. I hope you found it helpful and have a great rest of your day. Bye, y'all.